Welcome back to the workshop and yet another episode in this drill press modification. Those of you who watched the last episode will have seen me make this belt cover from a sheet steel. So we cut it out of a net shape, folded it, welded it, sanded, ground it, and then painted it, and then we put it on the machine. You'll also notice it's no longer on the machine, and that's because we're going to have a look at those pulleys that are really badly out of true. Got a lot of run out on them. Okay, in terms of the setup, I've taken the belt off. We'll talk a bit more about that in a minute. And that's given me access to the underside of this, and I've just got a DTI on there. So what we'll do, I'll bring you in close. So basically what I'm going to do, I'm just going to turn the quill at the bottom here. We'll see this pulley go around, and I've got it about 3/4 of the way out, which is somewhere near the pitch diameter for the belt. It's sort of the effective diameter, if you like, or the effective running area. I don't want to go right out the edge just in case the belt doesn't run there, and they may not have machined that deliberately, who knows, to save some money. So it's definitely where the belt runs, towards the top, and we'll turn. So we're currently on, let's just find the low spot, somewhere there. So we're currently on 0.3, I don't want to adjust it, so I'll probably move it. This is not magnetic, so I'll have to clamp it with just a regular clamp. So here we go, we'll go one full turn. That's about around there, so that was about pretty much 0.5 millimeter. Yeah, more or less 0.5 millimeter run out. So if you can imagine, every time that's running, it's basically causing it to shake and not run very smoothly, and we don't want that, do we? So that's that one. You can see probably visually, so I'm shaking the camera a bit, but they're all out. Now somebody did suggest, you know, maybe you can hold it in the lathe somehow on this feature here, and then re-sleeve it and bore it. Possibly an option, but this is on a taper. So there's a left-handed nut at the top there that holds this, and there's an internal taper, and the top of the spline has a taper, and it seats onto there. So yeah, I mean, it's all doable. I've just got to think about my options. Okay, so next up I think I'm going to actually take that pulley off and have a look at it, and then have a look at the taper, because you know, chances are I'm probably going to end up remaking that pulley from scratch. So let's have a look and see what the dimensions of that are. And then to lock it out, I've just got the wedge in there that you normally use to take the chuck out, or the arbor out at least, and that will stop this rotating. Now my particular drill press, it's a left-handed thread on that nut, so if you're doing this, just watch out for that. It might be left on yours as well. So we'll go up there, undo it, and then we can take the pulley off. Right, let's get, I think it was a 32mm socket in my case. Okay, so with a bit of luck, should be that way. Oh yeah. Okay, now this is on a taper on here, so I assume it's probably going to be quite tight. Oh, that was a bit of luck. I was about to get the pullers out. Okay, that's fine. So that's the drive taper. Yes. Okay. Right, well, we've got the pulley off now. I'll have a quick look at that. See you on the bench. If you look at the belt, so it's an 0610 1205. I haven't found an awful lot of reference to this on the internet. Closest I can get is something like some kind of washing machine belt. Now if you measure the width of this, this is 9.24. So V belts tend to come in standard sizes, so they start at A, go up to G. So A is about 13 millimeters, I think it is, yeah, 13. And then they go up in steps of 1 or 2 millimeters all the way up to about G. And then there's a smaller one, which is Z. They must have run out of letters and then gone back around again, and that is about 10 millimeters. So it's not really 10, so it's even a bit less than that. So I think rather than try, you know, when this wears out and making pulleys and whatever to suit this, I think we're going to start again, and we'll get a proper taper lock pulley that goes onto the shaft of the motor. I think it's 24 millimeters internal, and the taper lock goes on there, and then that's like an adapter that then holds the main pulley, be about 63 millimeters. And we'll go for the A section, so a proper standard size. That's what we'll go at one end, and then the other end we'll make a custom pulley that goes onto the top of the spindle. This is the current pulley, so it's got a couple of things I want to replicate or get close to. So this diameter here, and this groove here the belt runs in, and this one, these are the two I want to keep in the new pulley design. But obviously I want to make them fit the A belt. None of the rest, I don't need any of those because I've got the inverter, the variable speed, and I've been running on this one for most of the time, but there's a slightly larger one there, so if I really need that extra torque, I can loosen the motor, move the belt forward, go onto this pulley and step it down a little bit and get a bit more torque. But most of the time should be able to get away with it running in that one. And then the other thing is, so it's all cut away here, and that there is a taper. Now I've had a look at it and it's a bit of an odd one. I think it's 2.88 degrees, so it's too steep for a Morse taper and it's too shallow for an R8. So again, I'll have another look, but maybe that's an oddball taper as well. Not quite sure. If anyone knows what that is, about 2.88 degrees, let me know, that'd be interesting. Obviously I've got to honour that in the new design because that fits onto the top of the spindle. That's on the drill, unless I remake the spindle, and yeah, let's not go there, shall we? So I'll need to honour that, but the rest of it, I'm going to make the piece that fits onto here. So let me show you the drawings. Okay, so this is my pulley design. So it'll be made out of aluminium. There's a couple of features to note. So first of all, here's that taper. So that has to match the existing top of the quill. And there's that 2.8815 degrees taper on that. It's quite shallow. We only need 30 millimeters of engagement. And then there's a recess in here, so you can see that there. That's the recess because the top of that then has a thread on it, and there'll be a nut that just sits into there and holds it on. Then I'll just put a little chamfer around the outside. Other features are, obviously we've got our two grooves there, so they are, I'll show you a bigger view of this in a minute, but they're basically 40 degrees, and then there's a little bit of space at the bottom because you don't want the belt touching the bottom there, you want it to run on the sides. That's where the torque is transmitted. So we've got our smaller one there with that diameter, nominal 64 and 88, but obviously the pitch diameter is a little bit larger than that. So it's a bit like, I kind of copied the pitch diameter that I was using on the original pulley because that seemed to work okay and give a good ratio. I think that's kind of it. Let me bring you in a little bit closer on our detailed one because that's my general view, you know, make sure I can get the stock of the right dimensions and then part that off in the saw, then get it ready for the lathe. But then when I'm actually on the lathe, that's going to be a little bit fiddly to follow. So I've basically just got, if I can't even fit that in, got this larger version here. So this one I'll just pin to the lathe, and it shows me the detail of the start and stop of each of the different features on there. So the way I'm going to approach this is, you know, the obvious thing to do, if you like, might be to make a form tool, but there's a lot of engagement there. So I'm just going to use my parting tool, take this between these two lines down to the correct depth or pretty close to it, leave myself maybe a tiny bit left on there, same there, and then just set the compound. So I've got this angle on here, 20 degrees, and we'll just slowly feed that in and take that off, sort of cutting on the edge, if you like, that side, and use the DRO to work out when we basically form that kind of shape, and then I can do some kind of finish pass along there. Same on that one, so they should be okay with a bit of setting up. And then the rest of it is just turning to the sort of basic diameters before we start. So that side of it hopefully is fairly straightforward. So in terms of the stock to make this, I've had this piece for a long time, and that diameter there is about 110 and I need 98, so it'll be most of that. As you can see, that's a pretty long piece. So next thing I've got to figure out is the best way to cut this down to size, and then the order of operations in the lathe, because I've got to make sure one of the operations I do is this taper and cutting these in the same setup, so don't move anything, so they're concentric as possible. Obviously I've got to machine it from this side and from that side, so it probably makes sense. What I'm kind of thinking at the moment is cut out an oversized piece. Maybe I've got another 20 millimeters here, and when I hold it this side, probably in the lathe, I think I'm going to hold it here somewhere on the blank stock, turn a spigot on the end here, and then machine this pocket away. So then I've got an inside part and an outside spigot to hold on to, then turn it around on the lathe, hold on to that spigot, or I can hold on to the inside of that because it'll be a much longer piece. Then I can machine the taper and all these features. Then when I'm finally done, turn it round, and then this is not critical anymore. I can just hold this and just basically part off that little stub that was holding it in place, just the piece here. So that's my thoughts at the moment. I may change my mind as I kind of think it through, but that's what I'm going to do. So let's get the stock cut out. Yeah, what we need to do is first is get this set up on the lathe, and we need to read off this taper onto the cross slide, so we get our internal taper correct, so we'll match it off this. So I think what I'm going to do is get a spare piece, not this piece of stock, it can be quite small, get this in the lathe, get this taper measured, and put my spare piece in there, drill and move the cross slide to get that taper. Then I can blue it up and try it onto the end of onto the quill, and if I get a good contact pattern, I know I've got it set up pretty well, and then just don't touch it from there. I can do all my machining operations, just don't touch the angle on there. And then when it comes to do this for real on this part, we know it fits. So I think I've got 3 major steps to do. So let's get started. Okay, I swapped over to the 4-jaw, and then I've just been dialing this in and moving it around, and I'm just picking up on the edge of that taper there, and as we spin it around, so it's 0, 0, 0, 0, and then drops about 0.07, then back to 0. So I think there's probably just a local surface imperfection in the taper, because the rest of it is fine, so I'm clearly not going to be able to dial that in. So that's at this end. Right, we'll do a few more checks just to make sure we're not at some funny angle, because we need to pick up the true angle of this. Right, I know it's not easy to see, but I've got it about as far in as I can go. It's not quite to the bottom, but it's pretty close. And we've got the needle up there on 30. Spin that round. Bobbles a little bit, but I think that's the surface imperfection. Okay, looks good. So I think we've got the taper centralized and concentric in the 4-jaw. So let's set up our cross slide here, or our top slide, sorry, and pick up that angle. Oh, that was funny. I'll just reenact that because I wasn't filming. So we wind this, move it in, and absolutely perfect, nothing happening. Hang on. That's because we've got the base on the cross slide, so we'll reposition it onto the top slide, and then we'll try that again. Alright, some considerable time later, after messing about with it, I think I've got it pretty close. I think one of the problems is the bore inside there is very rough. It's not, you know, nicely machined. I think there's a little bit, just as you come out towards the lower edge here, I think it's slightly tapered out, a little bit bell mouth. Whether that's by design or just poor machining, I don't know. So I've got it very, very close. I'm kind of tempted to lock it off and go with that and cut the test piece and then see what happens. So we're about 0 there, and let's wind it in. So it bumps about a little bit, and goes up to maybe 0.04, and then when we get towards the top end, it sort of comes back into 0. So I'm sort of wondering if it's just kind of badly machined, and maybe we'll go for that. So I think what we'll do, we'll lock this down, then we've got the angle there in the top slide, and we'll cut our test piece. Before we do that, a thought occurred to me. I wonder if this part of the taper is particularly round, particularly accurate. So we've got our test indicator on there, and we're back to this piece of steel back here. So we'll just turn the quill. So that's that, about 0.15. Now I could probably go over this with a bit of light emery or something like that, or something a bit milder, maybe even some Scotch-Brite, just to, yeah, you can feel a few dings in there. We'll pick another 2 random positions and see if it's the same. Okay, we're a little bit lower now. I'll just turn it again, so we're on about 0.13. Yeah, 0.13. It's better, but there's about 0.06 there. Right, let's try at the bottom. Alright, we're at a different position now. We'll spin it round. About 0.05. So, I mean, is it the bearing? No, it's not free play. It's just the machining. Okay, I think we'll put some Scotch-Brite over this and just see if we can clean up the worst, these little nicks in here. Maybe that'll improve it, but I'm not going to make a new spindle, okay? We're going to make this work. We're just going to use what we've got, do the best we can. Okay, I'll clean it up and then we'll see if that improves it. If not, we'll take it from there. Okay, so I've just ran over this and cleaned it up as best I can. Is it any better? Still 0.1, so that's probably about as good as it's going to get. Okay, alright, well, let's make the pulley. At least it'll be better than it was. Right, so swap back to the 3 drawer, and we've just got a test piece in here. This is a piece of scrap, and just by complete chance it is 30mm, which is just what we need for the bore. It wouldn't matter if it wasn't. We were testing the taper out, but you know, since it's the correct length, we'll use that. And the taper starts at 25.31 at the top, and it goes to 28.33 at the bottom there. So we've got a boring bar in at the moment. We'll take it all out to 25.31, and then because we've got the angle set, remember we traced it from the original pulley on the top slide here, we'll just start taking away the corners until we've opened it up to 25.33, or pretty close, because again we're just basically testing the taper. So I'll get this switched on, we'll touch off, and then we'll start cutting our taper. Okay, we're looking for 25.31. I don't think we're quite there. Looks like we're at 25.24. Maybe 25, so about 0.06 to take out. Just took it past 25.33. So we're shooting for 25.31, we've got 25.33. Okay, we'll go with that. So we've got our minor diameter. Obviously this end is now too small, and we just need to take away the edges, and we'll keep going with the angle we set on the top slide here until we just remove the last piece back here, and then we've formed that perfect shape, and then we're ready to test it on the drill press. Alright, so I've got the carriage locked, and we've got obviously the angle dialed in, so we're going to turn the top slide and just keep taking little bites away until we're there. So I've taken one of the handles off to make it a little bit easier. I could weld up a little T-handle and then run it in a cordless drill. That's a pretty popular option, but yeah, this shouldn't take too long. I'll just see how fed up I get with winding it manually. Right, so let's start it up. I've put a little bit of a cut on there. Yeah. Alright, let's take it away. So I think we're about there. So if you look down in the bore, you see it's virtually gone to the end, and there's a little bit of material just there, which is basically where it's just pushed a bit of material out. So for it, there we go. So we get to focus on that. Probably not. Oh, there we go. So the fact it's pushed that material out means it's pretty much cut to the end. So I think we'll go with that. I'll clean that up, and then that will be our test taper. So we'll take this out, clean that up, and then I'll see you over at the drill. Okay, so here we are back on top of the drill. Now, I was holding it here, wasn't I? Now, I know that's not machined concentric to that, but I guess we can set the test indicator up on there and just have a look, just out of interest. But in terms of fit, I've got some blue marking paste for looking at interference fits and contact area. It should have arrived by now, but it's not here yet, so when it does we'll give that a try. But just feeling it feels pretty good. Right, we'll put the nut on and then just see how much torque it'll take, and then with the nut we know it's seated properly, and then we can put the test indicator on and just have a look on here to see what we get. Right, here's our nut and left-handed thread. Alright, I'll just nip, I'm holding the camera and doing this, so we'll nip that up and then I'll bring you back in a minute. Okay, I haven't done this super tight because obviously I want to get this back off, and I was just a bit worried I might not get the puller under there in case it gets stuck, so it's on, and then we've got this 0. Now remember, I think there was 0.0115 maybe run out actually on the top of the quill itself, and obviously we were holding this in the 3 jaw and we've just machined the centre relative to that, so you know it's not a perfect part, but let's have a look and see what we've got. So we're on 0. About 0.011, so pretty close to the run out on the top of the spindle itself, so you know, maybe this is okay. I guess, you know, I could try this in a couple of positions and see if there was a minimum, if there was any run out on this, but it's obviously only a test piece. What we really want to know is it gripping the top of the taper? So until my marking blue arrives I can't really check contact, but what I think I might be able to do is just try and see if I can move this by hand, so let's try that. Okay, so I've got this locked out here so it can't turn, and it's hard up against one edge, and I'll just try and turn it by hand. That's all I can really do. And I can't move it. Obviously not a definitive test, and if I'd have had a bit more material I might have been able to put a little bit of a V in here and then actually hooked a belt up, even though the ratio's wrong, just to give me a start. But I think for now, until the blue arrives, the marking blue, I can't check the contact area. Maybe what I'll do now is just take it off and just see if there's any witness mark about what the contact looks like at least, or well, I can try it with a Sharpie. Yeah, let's try that. While we wait for the correct stuff to come, I've put the Sharpie on there. We've got to be quick before it dries, so let's give that a try. Right, well, let's take it off and see what we've got. And the answer is, I'll take the wedge out, there we go, then we can turn it. So there's a little bit here. Okay, so I think we're making contact maybe at 2 places. Quite a lot at the top. Yeah, it might be just the top. Oh, hang on. There's a little bit. There's a little bit just down there. So, patchy, but then this is not the right stuff. You know, that the actual marking blue is a mixture of grease and I think a cobalt blue dye. You know, so it stays liquid and do a better job. But until that arrives, as far as I know, that taper's reasonable. Right, so let's make the proper part. Okay, so we've got our piece of material, now we need to cut it down. What I've decided to do is on each end of the pulley there'll be a little bit of a spigot so that we can basically hold it at one end, start some of the features including machining the spigot at this end, turn it round, hold that spigot we machined, and then do the internal taper and the pulley features, and then right at the end we turn it round and we machine that spigot off because we don't need it. So we've made it a little bit wider than we need so we can get the 2 spigots out of it. It's quite a lot of material, isn't it? But you know, that's what it needs. So we'll cut it off there. I've allowed it just a little bit more. You know, more is always going to be better. And then once we chop that off, we can get it set up in the lathe. Now, I'm going to need to, yeah, I'll have to look at my jaws, see if the outside jaws are going to hold that. It's getting quite big, isn't it? But anyway, we need to chop this off, and then we'll take it from there. Well, it is supposed to cut up to 5 inches, 125 millimeters, and it certainly does that. You wouldn't really want to do that with a hacksaw. Alright, let's get it out of here, and then let's hope we can fit it in the lathe. Actually, before we do that, how flat is it? So across that way is pretty good. A little bit of rock in there. Yeah, maybe a millimetre out, but pretty pleased with that because the machine really is for roughing stock out. Right, let's go and get this on the lathe. Okay, so we've got the stock in the lathe there. As you can see, it's pretty big, but we've got the outside jaws on there, and we're quite a way into the scroll there, so we've got a reasonably good grip. But even so, I'm going to put a centre on there. We'll take this down to within 2 millimeters of the final size, and then we'll machine this flat and put the spigot on this end, sort of the extra piece that'll stick out the front, and machine the pocket. Then we'll take the centre out and do the pocket here to finish size, and then I think we'll take it out, hold it on that newly machined spigot, and do the rest of the machining from the other side, which includes the taper and the V's there. And then finally we'll turn it back around again, hold it on the finished diameter, and just remove that spigot that we've just put on there for convenience. Right, so we'll drill and put the centre in, and then I'll bring you back. Now this lathe, we're a little bit at the limit, so we've just got to be a bit careful, because if I show you under here, the jeweler is coming very close. Yeah. So another few millimetres and then it'll hit, so we're just got to be very careful. Right, onwards. Okay, so I've just been facing this off roughly, so you can see it's pretty rough there, just been hand turning it. I can only take a little bit at a time, but I'm going as quick as I can because it's such a large diameter as this and the torque of this lathe, you can stall it out. So just making steady progress there. I've also faced this off, this is my 0 now, and then just to double check, that's going to be my spigot, which will be sacrificial, so that will get turned off at the end. So that's to give me something to hold when I turn it around. And then I've just double checked that I'm going to fit the part in here, and then I've still got a little bit here to hold on to it from this side. So it looks like it's going to work. So now we've got that marked out, we'll just turn this away to create our first feature, or temporary feature at least, which is the spigot. So let's machine some of this back. Okay, so we've got our spigot turned there, so that should be, oh, it's not critical, but that should be 62 diameter and then 20 deep. So let's just see, at least it gives us a chance to get the lathe dialed in. 6203, yeah, we'll take that, and the depth, not so easy. Oh yeah, okay. Alright, 20. Okay, so spigot done. Okay, next up we'll take this down to 100 millimeters. That leaves 2 millimeters of stock to remove when we've turned it round, and then we can take the live center out and we'll bore this inside here, and I think we'll drill a hole all the way through just to get us started. Maybe 18, 20 millimeters, something like that. Right, let's bring this down to size next. Oh, I love machining aluminium. Okay, so we've got our spigot finished to the right size. Obviously this is just to hold it when we turn it round, and that will be removed right at the end. Then we've got this stock's a little bit oversized. I think I added about 2 or 3 millimeters onto the final dimension there, just to give us something to turn down to. We're just going to take this out to about 20 millimeters, and then we'll do the counterbore inside here, which is where the nut goes to secure the pulley. Right, let's get drilling. Okay, so I think we've finished the turning on that side, so this is rough to size. There's still a bit of stock to remove there. We've got our spigot we can hold on to when we turn it around. That counterbore in there I've just checked, and yeah, the socket will go in there, which holds that left-handed nut on top of the spindle, so that's fine. And then that's deep enough, you know, so when this is removed you've still got the pocket inside there. So I think I'll double check the drawing. I think we're ready to turn it round now. This is obviously now going to be machined away, so I think the best thing to do, I'll put it in the saw, hold this, and then we'll cut most of that off and then just take the rest off with a lathe, and then we can bring it down to the final size and do, well, the rest of the machining. So we'll have the taper to do, and then our 2 V-grooves for the pulley. Right, let's get it out of here and chop that bit off. So as you can see, I've got it turned around the other way now. I'm holding it on that spigot, and I'm just taking this rough stock off the back here. So we'll bring this flush, then measure that and get it to the correct dimension, and face this off. And then we've got a choice. We can either start doing the taper, or we can do the pulley V's in here. Well, let's get this sorted out, and then we'll decide which one we're going to do next. Okay, it's a bit hot, but I've got this down to size now, so that should be 44. Yeah, 4406, that's fine. That'll come down a tiny bit when it's cooled down, and then the diameter should be 98. It's not easy to measure. Okay, that's fine. Right, so I think what I've decided to do, we'll do the taper next, because I've got the top slide set at the correct angle, and you know, just in case I'm doing the grooving and it knocks it and pushes it out, I've lost all my datum and then I'm really stuck. I'd have to put the original part back in. So I think we'll do the taper next and bring it out to final size. Okay, so we've opened up our bore now, and I'm just using the boring bar just to bring it up to 25.31, which is the minor diameter of that taper. And then we'll use the top side here that's got the angle onto it just to grow that taper out by taking away from this corner here until it matches up, and we should hit about 28.33, and that should give us the taper we want. So let's take this out to the minor size, and then we can use the top side. So we should be at 25.31 or pretty close. Let's see where we got to. Uh, 25, yeah, 31, just a touch past. Okay, we'll take that. Right, so now we need to take away using the top slide and get our taper. 'Kay, I marked up the whole of this with blue Sharpie, and you can see as I'm now taking it away, there's a little bit left, which is the flat area, the original diameter, so we need to go a little bit further, but we're getting close now. Okay, I've just done one more pass on there. There's a tiny bit of blue left. I'm kind of tempted to leave it because I just took a measurement. Now it's not easy because this is a taper obviously, so I'm just trying to pick up off the very start a bit and get a bit of an idea. So we're looking for 28.33 or close to that. It's not super critical because it's a taper obviously. We're currently coming in about 28.34. So if I do another very fine pass just to take that last bit of blue out, this will be a bit larger, and it will basically mean this will sit a bit lower. And I'm a bit worried about that because we might, it might sit in slightly the wrong place. So I think, let's just measure that again. Yeah, maybe even 3.4, 3.5. Oh, missed it completely. Again, it's a taper, so not easy to measure. Yeah, just on the edge, yeah, 3.4. So I think we'll leave it there. We got that done. I'll just check this. This is machined true. I think we needed to take maybe a tiny bit off here, and then we'll start to work on the V pulleys. Okay, so we've got our steps now to the final sizes, so we'll just glue this bit up and then we can put the parting tool on to mark the V's. Just do it nice and slow. Here we've got the top slide set at 20 degrees and I'm just taking the corners off there and then feeding it along until we get right to the bottom there. Alright, let's keep going. Anyway, that looks pretty good, so let's just try the belt against that. So I wanted it to be about flush, which I'd say it is, and then it needs to grip on the sides and not touch the bottom. Don't know if we can see that. Yeah, about 4 or 5 mil clear, so that's fine. So give it something to grip into. That's going to work well. Okay, so next up we need to set everything back up again for this groove, and then we're done. Okay, so I've taken that one down to final depth there, so all we need to do now is set our angle to 20 degrees and keep taking off one edge until we just touch the bottom, and then same with the other angle until we touch the bottom there, and then we'll just round over all these edges, and yeah, that's the V grooves done. Right, let's try it again. Yeah, that looks good. Just, yeah, I think when it's got some tension on, that'll be almost flush. And yeah, it's nowhere near the bottom. Okay. I think the V grooves are done. So I've got a little bit of cleanup to do in there, but that's fine. Alright. Okay, so we're all set for the last operation. I've swapped the jaws around, so we've got the external jaws, got a little bit of packing here just to protect the finished surface. And we set this square to the surface here. We'll just use the parting tool to take most of this off, and then we'll come in and clean up with the normal lathe tool, right-handed lathe tool. Right, so let's part off this ring. Well, there it is, all finished. I've just cleaned up some of the edges, put some chamfers on and so on, and yeah, very pleased with that. So I think we'll just try it on the drill press on the taper, see if it fits. I won't permanently put it on because we've got to look at one more thing. I'll show you that in a minute. But I guess I better offer it up and see how well we've done. Pleased with that. Right, see you at the drill press. Wow. That's good, it clears. Oh, you can't quite see there, I'll just lift you up. See it? That was what I was worried about, if the taper went down too far that was going to hit, but looks like that's gone okay. And have we got enough thread in there? Looking into the camera, yeah, I think so. Just right, well, as you can see, I've got the dial indicator set up somewhere towards the outside where the belt will run. I've zeroed it. Now remember, the top of the quill itself, the taper that it sits on, had about 0.1 millimeters of runout already, so the best it can be is 0.1 really. But remember, it was about half a millimeter, maybe just a bit more, so that's on 0. 0.07, back to 0. Okay. Well, it was never going to be 0 because the runout was already there, but also it's not 0.07, is it? So 0.1, 0.12. Well, given that it was half a millimeter before, that is a good improvement. And apart from remaking the spindle or somehow grounding it in situ, yeah, more projects, isn't it? It's projects all the way down. Perhaps that's as good as we're going to get. Well, let's see how it runs and see how vibration free it is now, and see if it still sort of kicks a little bit. Oh, hopefully it should be a little bit smoother. Okay, let's talk a little bit about the taper lock pulleys. So these are the ones I bought. This is the one that will go on the motor end, and it's got this tapered bore, and then you'll see there's a thread that side and a thread that side. Those are to actually put the insert in, which does the gripping. I'll show you that in a minute, and it locks against this taper here. And then if you want to get it out again, you can use one of the grub screws as a jacking screw in the top slot there, or the top hole, and push the grub screw in, and then it pulls the taper out, otherwise it will jam in place. It's an A section along there. So let me just show you the insert. So the insert looks like this, and you can see you've got the two blank pieces. So those are what line up with the threads on this side, and then there's an open bit here, so allow it to compress down. And then when you want to get it out again, you can put a grub screw down there, and it kind of jacks itself out. So if we just look at this in terms of alignment, we need to line up the two blanks in here with the two threads in there, so something like that. And then we can put our two grub screws in there. I'll just lightly put them in, and then we'll offer it up to the drill, get it in about the right place, and then this taper will clamp down onto that collar, and that should lock it nicely in place. Then we want to get it out, we remove one of these grub screws, or remove both actually, but use one to go into there, and that will just push this tape back out again. So that's kind of how it works. So we've got our two grub screws down here. So I'll put the first one in there, second one in there. Okay, so it's loose but it's ready to go on. Okay, looks like they maybe balance it as well. It's quite nice. Seems quite nicely made, so hopefully this will be nice and true. Let's go and fit it to the drill. Okay, I had to spin the motor around just to get the old pulley off, because there was a bolt in the end there just stopping it coming off. I don't think I'll use that again, because it'll be pretty difficult to get it off, because you don't have access to the underside of that. It's too close to here. Second thing is that the key itself was way too deep. It was sticking way up here, and when you put the taper lock pulley on, see the keyway there, it was never going to work. So I just took this over to the CNC machine, measured it all up, took a couple of millimeters off, so it's just got the correct dimension now. And now it's quite a nice little, try and do this one on it, there we go. Quite a nice little sliding fit over that. Obviously that'll tighten up when we do up the taper. So that's good. So we'll get the pulley on there, get that set up square, get the belt aligned and tighten that up, and then I'll bring you back. Okay, well there it is, all lined up, and slight problem is that, as you can see, the tension's not great and it's fully rearward. Now I did order two belts just in case, I was going to get a bit marginal on the size calculation, but the other one is a little bit bigger, so I'll need to order the next size down, and probably the next size down below that. Just they're only a few pounds each, so just make sure definitely get the right size, and then it will definitely fit on there as well. So it's a little bit loose. We'll just see how it runs. It may stall out, I don't know, but at least basically we got it made. We've got the keyway sorted out, we've got this machined, it fits on here, it's reasonably concentric, there's a lot less run out than before, and that fits on there quite nicely. It's a bit awkward to get in here to get the Allen keys to if I need to move it up and down. So another thought I had was, I wonder if I can just buy another one, maybe just take advantage of a different size. If I want to run this, then I just only need to swap the belts, move the belt up and down, adjust the tension up here. So I think there's space to put another one on there and get it aligned to this. Anyway, that's for the future. So let's just see if we can drill something and just see how it sounds, and does it run a little bit smoother than before. Okay, I've got a piece of scrap in here. We'll just see if we can drill a hole at least. It may slip, I don't know, because the belt's not super tight. But let's give it a run and just see how smooth it feels and how we get on with it. Right, so here we go. Yeah, so there's a lot less vibration in it now. Let's see if we can drill a hole. Well, that went okay. I guess it just goes to show how tolerant these belts are, although I will get the right belt size and then we'll get the correct tension, because I imagine anything larger than this and it'll probably start slipping. yeah, pretty pleased with that. Good. I think that's it for this video. I'm really pleased with how that turned out. It's a lot less run out, seems to run a lot smoother. I say I'll order a shorter belt and maybe one a little size down from that. Maybe I'll double up on those, but yeah, I won't necessarily video that. So as always, thank you very much for watching. Hope you enjoyed, and see you next time.